Almost every science textbook in the physical sciences, chemistry and physics, has a diagram of the Rutherford Scattering experiment, which was performed and ultimately ascertained that we had in gold foil dense nuclei. The experiment consisted of an alpha source shooting heavy alpha particles through a very thin gold foil, and then using detectors, zinc sulfide detectors, the actual flow of the alpha particles was detected. What most students get misrepresented in terms of this diagram is the fact that in the textbook we get the impression that this was some big piece of gold foil and that this was some big apparatus. And in fact, if we know anything about alpha particles, we know they don't travel very far, number one. Number two, we know that they are going to be stopped by almost anything. They bounce off skin, for example. So the diagram is really quite a misrepresentation of what happened, because what they were doing was working microscopically with a very small apparatus and making measurements that really couldn't be seen by the naked eye. They had to be magnified, because as the alpha particles struck the screen, the sparks of light that were generated from the zinc sulfide were barely perceptible. So it always bothered me that this was the concept that students had, that there was this great big bar of gold and they were shooting these alpha particles through it. And one day I thought to myself, how can we better demonstrate this on a realistic level, almost, and on a level that they would be able to understand regardless of their knowledge level or their ability to perceive or conceptualize what was going on. So what I did was I created this device, and it is very simply, as you can see, a piece of cardboard standing on four legs. To simulate the nucleus, what I have done is to put a target and a solid object underneath so that we would be able to simulate the alpha particles. For alpha particles, I'm using ping-pong balls. Now, as we roll the ping-pong balls underneath, we notice that the first one comes out to the side. However, as we do this, they will more and more go straight through. Occasionally, one will bounce straight back. But if we continue to roll these through, the alpha particles are going to, for the most part, go directly through. And we can see that once in a while one will deflect off or come back at us, but that most of them will in fact go through unaffected, which is a simulation of the black box of what Rutherford students were attempting to describe from the results of their experiment. And such a demonstration is very simple, very concrete for students to understand. Now, being a black box, we have to be careful. If you know the term black box, it's something that we are inferring from, and we're not necessarily sure that what we are inferring is correct. Using this in the classroom, you would then ask the students, what's here? What is this? You wouldn't tell them ahead of time, but you would ask them, what do they think is there? Students will make all kinds of predictions. The key factor that they have to realize is that there's something there, and there's something that stops some of the ping pong balls from going straight through. Is it totally accurate? No. Is it a good representation on a very basic level of what was going on? And I feel it is. Now, the key factor here, and you have to use your own judgment call on this, is do we then tell them or show them what was going on? That's up to you. How far do you want to go? A true black box, they don't know the answer. You just let them go away, and after their explanation, you accept it and you say, does that explain what you observe? And if it does, and you're satisfied with it, then that's the explanation. So that what you're doing is introducing them to scientific modeling at a very simple level, and you are also then introducing them to the concept of sometimes we really don't know the final answer. And we are modeling a picture that they have seen in their textbook on a more realistic basis. The device, in case you want to prepare one for your own use in your own classroom, is just a very simple device. As I said, it consists of a piece of cardboard. The shape is not important. This particular piece of cardboard is more than adequate. I've actually used a soda flat, if you know what that is, a cardboard box. Put 4 corners on it. In this case, I have simply hot glued some corks onto the corner. Just remember one thing, it has to be high enough for the ping pong ball to freely roll underneath. I have simply glued a heavy object to the bottom. Again, hot glue. This is a AA battery, nothing special, so that I have a target. When you do the demonstration, if you know where the target is, it makes it a lot easier, because then you can sort of know where to aim and where not to. You want most of them to go through. So you can, in some way, position it. I knew where the solid object was and was able to occasionally specifically aim for it. But it's a very simple device, nothing to it. You can build one every year, or you can just make one and put it away and save it for future year's use.